Mechan 2410 Engineering Materials Tutorial 7 Diffusion. Diffusion is an important phenomenon in terms of the materials, and in material engineering and in material science, we often use this phenomenon to strengthen our materials. And in industry, there are actually many types of material processing that utilize the principle of diffusion to strengthen the materials. So in this tutorial, I will talk about what is diffusion, diffusion mechanism in solid material, steady state diffusion, which is governed by Fick's first law, and non-static state diffusion, which is governed by Fick's second law, and diffusion in semi-infinite solid. Tutorial 7, Part 1. Diffusion definitions and types. Definition of diffusion. Diffusion is the movement of an atom or a group of atoms down a concentration gradient. And it is normally initialized by the difference, usually the concentration gradient or the temperature gradient, between two regions. You can observe the process of diffusion in the following pictures. In the first picture, the two regions are distinct, and two types of atoms, the red atom and the blue atom, haven't mixed. But after diffusion process, or during the diffusion process, these two types of atoms mix with each other, and the concentration gradient, the movement of the atoms just follows the concentration gradient. And there are several examples. In daily life, we can mix water with different temperatures. And for example, if you mix a cold water with a hot water, you will get a warm water. And if you mix milk and coffee, you cannot distinguish the mixture in milk or in coffee because it is mixed. And basically, it is done by diffusion. However, diffusion also happens in solids, and such process is our point of interest. During diffusion process, the entropy is increased. It is because after the atoms diffuse into each other, there is more possible ways, more possible arrangements to arrange the atoms. If you still remember the equation I introduced in tutorial 3, which talk about the statistical definition of entropy, if a system has more possible states, in other terms, more possible ways to arrange its atoms, then the entropy level is higher. If you want to know more about such definition of entropy, I suggest you to take the 4000 level physics courses, which is thermodynamic and statistical physics. In terms of the types of the diffusion, it can be separated into two types. Interdiffusion, or in other words, impurity diffusion, which is the first type. This kind of diffusion describes the diffusion between two different solids. For example, if you connect copper and nickel plates together, which will form a diffusion couple, and the interdiffusion or impurity diffusion will happen. The second type is the self-diffusion. It is the diffusion within the same solid. For example, even within the pure metal, the diffusion, the atoms, can move within the metal, and that is the self-diffusion. And there are two types of diffusion mechanism. The first one is the vacancy diffusion, and the second one is the interstitial diffusion. There is two criteria for diffusion. to occur, the first thing is there must be an empty adjacent site for the atom, for that particular atom to go within there. And the second is the diffusing atom must have the sufficient energy to break the original bonding or original forces with each neighbor atoms. Vacancy diffusion involves the interchange of an atom or impurity from its normal lattice position to an adjacent vacancy site. During vacancy diffusion, the position of the vacancy and the impurity atoms are exchanged in vacancy diffusion. And therefore, the higher concentration of vacancies, the higher diffusion rate. Vacancy diffusion can be described by the following picture. In this picture, our red atom is diffused to the vacancy site. And you can see that during this process, the position of the vacancy and the red atom are interchanged. Both interdiffusion and self-diffusion can occur by this mechanism. For interdiffusion, there is at least two kinds of atoms involved. The impurity atoms must substitute for host atoms, and that means the size of the impurity atoms is close to the size of the host atoms. And if you still remembered in the defects tutorial, we talked about the substitutional impurities. And basically, the impurity must be substitutional impurity to have a comparable size between the host atom and the impurity atoms. And obviously, self-diffusion can occur by this mechanism because in normal solids, there is vacancies within the normal solid, and you can just move the atoms within vacancy, in and out of the vacancy, and that's basically the vacancy diffusion within a single solid. Interstitial diffusion involves any migration of impurity atoms from an interstitial site to neighboring empty interstitial sites. Interstitial sites you can consider as the space between perfectly packed atoms. Because we know that even for perfectly packed atoms, there is still some spaces between them, and which allows the migration of the much smaller impurity atom into those spaces, as described by the picture here. You can see that even the blue atoms are perfectly packed. There is still some spaces which allows the much smaller red atom to diffuse into this blue atom piece. Therefore, the impurity atom must be much smaller. For example, carbon, nitrogen, or oxygen than the host atom, so that they can fit into the interstitial sites. The interstitial diffusion can only happen in interdiffusion. That means two or more types of atoms. And this is pretty much very easy to understand. If there is only one type of atom, the atom size is not suitable for such diffusion mechanism. And if you still remember, in the earlier tutorials, we talked about the crystallographic defects. And basically, interstitial impurities is those red atom and those impurity atom. And the interstitial diffusion has a higher rate than vacancy diffusion. As obviously, the number of interstitial sites are much more than the number of vacancies. And also, smaller atoms needs less energy to move. That means they are easier to move. There is an example to test your understanding of these two diffusion mechanisms. What is the diffusion mechanism of the atoms within, first, an isolated piece of steel, second, an isolated piece of brass, third, an isolated piece pure iron, and finally, a piece of pure iron in contact with nitrogen gas? The first thing is all materials can have vacancy diffusion mechanism, as vacancy will always exist for a material, and that implies the vacancy diffusion can happen. For steel, both vacancy diffusion and interstitial diffusion will happen. The first thing is steel is an alloy of carbon and iron. The carbon atom is very small compared with the iron atoms, which allows the interstitial diffusion of carbon atoms within steel. For brass, there is only vacancy diffusion. It is because brass is an alloy of zinc and copper. For zinc atom, they have a very similar size with copper, and that means for both zinc and copper atoms, they cannot diffuse into each other. They cannot diffuse into each other's interstitial sites, and that means interstitial diffusion cannot happen. For pure iron, there is only vacancy diffusion, and there is no other chemical species. For pure iron in contact with nitrogen gas, both vacancy diffusion and interstitial diffusion can happen. It is because nitrogen atom is very small compared to iron atom, and even for nitrogen gas, in gas state, the nitrogen atom can still diffuse into iron piece, and which allows interstitial diffusion. Diffusion is a thermally activated process, and the activation energy for vacancy diffusion is larger than interstitial diffusion. And basically, you can see from this picture here, I use it for the textbook. For the substitutional diffusion, the atom is much more larger and the energy required is higher. And for interstitial diffusion, the atoms are much more smaller and the activation energy is smaller. And obviously, for a reaction having a higher activation energy, it is much more difficult than for an atom with lower activation energy. For a reaction having lower activation energy, they will have a higher rate than a reaction having a higher activation energy in same energy level. This is also the other reason that why interstitial diffusion has a higher rate